Hi everyone, my name is Wim Vancauwenberghe. I'm the director of BIMAS, the Belgian Maintenance Society. Welcome to the Asset Performance Podcast. We are here today at Aveva Select Benelux, and I have with me Omar and David. Hello, welcome.
Very good morning, hi.
A good day to you, Wim.
Yeah, hello. So, maybe first of all, what kind of company is Aveva Select Benelux?
Well, Aveva Select Benelux is busy in industrial software. And busy in industrial software, why do I say that? We not only sell industrial software from Aveva, but we also make sure that customers get the most from their software. Meaning, we deliver the support, we deliver all the trainings, not only to the end users, but also the system integrators. And we make sure that we accompany during the projects of implementation and making sure that we validate certain things and making sure that the architecture is in place, correctly implemented, etc. And so that's why I say we are busy with, and in short, we are the knowledge center of Aveva in the Benelux.
Okay, so Omar, maybe you can explain a little bit what is your role at the organization?
My role is sales manager in the company. So I have a team of 6 account managers, and we work predominantly on end users in CPG, in life science, metals, for instance, but also chemicals. And we cover the Benelux. That is our mission.
Yeah. Okay. So David, you have a background in everything that has to do with intelligence and etc.
Yes, absolutely. So within Aveva Select, I'm managing our analytics team, and we provide analytics services towards our customers. Now, I have a background in the chemical industry. I worked there for 12 years. And before that, I'm a mathematical engineer. So I would say that modeling data, it's always been part of my story.
Very nice to have some experts around the table here today. So we're going to talk about asset performance, of course, and how what is your vision and the vision of Aveva on how that we can proceed with that, implementing that in industry. So in your opinion, what is asset performance? What is asset performance management?
Mm-hmm. Yeah, at Aveva Select, coming from Aveva, we don't necessarily speak about asset performance as a topic. We speak more of asset performance management. And for us, it clearly is more than just asset performance. Why? We not only speak about asset reliability or asset availability, but we also speak about the business context. And that business context is more and more important because we live in a volatile market currently, so it's even more important than 15 years ago. And questions that need to be asked are what is the financial impact on the production? What is the influence, for instance, of a changing supply chain on my production facilities? These type of questions are to be asked to give a broader business context. But also it's about the organizational capabilities. So the capabilities of the organization, the workforce management, the capabilities of the IT and OT systems, the processes, so the work processes, and how do they interact? Does that mingle correctly? So that is for us asset performance management. Now, a little bit of marketing lingo from Aveva. Aveva speaks about asset performance management 4.0, APM 4.0, and that is the real digital transformation. And so for us, that is bridging the gap, making sure that these IT, OT, and ET systems really connect, not only between systems, but also with the users. And so that is, for us, the true digital transformation.
Yeah, so it's the idea to connect engineering, maintenance, operations, quality, etc.
Indeed.
All together in order
Correct.
to increase performance of
that's it.
And output of the plant.
Absolutely, of the plant.
Okay. Perfect. So what is the mission of Aveva? What do we want to achieve there?
For us, that's clear. As Aveva, but also Aveva Select Benelux, I said earlier during the introduction, we want to help customers extract the maximum from the industrial software. And when looking at APM specifically, we want to help them balance their risk. We want to balance that with performance of their assets and also the cost of their assets and the maintenance of it. And so for us, that is the main, let's say, way towards operational excellence. And how do we do that? First of all, we try to help them manage their industrial information. or industrial data. It starts with the data, and actually helping them moving towards a good asset strategy that is built upon prescriptive maintenance mainly. So we want to help them go beyond preventative maintenance, predictive maintenance, and really move to prescriptive maintenance and help them build those strategies. Not only that, I said industrial data. Many companies have asset information, lying around the company or even outside the company, lying at EPCs, OEMs, you name it. And how do they manage all that information? This is where we actually want to help customers, get one single source of the truth, basically. So making sure that they can extract data from their real-time systems, OT systems. They can extract data from their ERP, because some ERP systems also have asset information. And we want to help them extract all the information from their documents, whether it be PDFs, Word documents, etc., but also plans, so like P&IDs, 3D models if they have them, scans, etc., and really make that into one single source of truth.
Yeah, so we're talking about digital twins.
Yeah, basically that's one of these aspects that could be involved, of course, is that speaking of a digital twin, it's not only the visual digital twin, but actually what is underneath as well. And that is the data, the information, to make sure that users can leverage the digital twin, basically.
Yeah, and that's why Aveva calls it an asset information management system.
Indeed. Yeah. So indeed. So Aveva's asset information management is one of these solutions that can really push the users to extract more and, of course, increase collaboration between users. So it's not only maintenance using these type of systems, but also engineering, because they need to provide, new, let's say, assets and information on those, but also operations, because operations make sure that the real-time data is flowing into this system. So that's a perfect example.
Yeah. Okay. So David, you're in constant contact with plants and people in the field, I would say. What are the main questions, the main needs that you encounter?
Well, it's fun that you say so, because that has changed dramatically in the last, since March this year, right? So you know what I'm going to say, right? There is not a single day where people are not talking to us, to me, about the impact of AI, ChatGPT kind of things, to their work, to their company, to there as a person in some cases. And the fun thing is there is this tool called Google Trends. I don't know if you know it. Google Trends is, you can use that to see what is the world looking for on the web in a certain region or entirely in the world. Now, the fun thing here is that obviously ChatGPT is the number one word searched globally. Do you know number 2 and number 3?
No.
Well, number 2 is actually the Indian Cricket Championship. Yeah. And number 3 is the World Football Championship. Okay. So just to say how important, what the impact of ChatGPT has been the last months, right? Yeah. Now, on the other hand, for me as a mathematician, it's not really new. These developments in these models, they have been going on for decades. I've been also developing them myself 15 years ago when I was still at university. So what we see is that there is this hype now created, but on the other hand, it's also not new for us.
Yeah. Mm-hmm. So talking about the hype, basically AI, these are algorithms, and they're calling these smart, but are they really smart, or are they rather stupid?
Well, I dare to say, Wim, and I might now, or you might now get angry fan mail, sorry for that, but I dare to say that AI algorithms, they are stupid. Oh. They are stupid, and I understand that needs some explanation. And it's always, I say that not only to people in the industry, but also to people I meet at just somewhere, people from my family or at the school of my kids or you name it. But people ask me, should we be afraid of AI? And I typically say no. But so let's go back to what is AI. AI, in my opinion, are computer algorithms who try to simulate cognitive functions. So they try to simulate how we think as a human, which is really, really hard. Nobody actually fully understands that yet, but we try to do that. And if we talk about machine learning, which is typically used in the if people talk about AI, they talk about machine learning. Now, machine learning is just one of those ways of doing that. And now I do have an interesting presentation of how that works, and I will be talking on that topic at the BEMA's conference. So everybody who likes to understand it more in detail, feel free to join my presentation. But in short, I always try to resemble a machine learning algorithm to how a baby learns. I've seen it happening just a few years ago, and a baby learns to do something by just trying, and at a certain point in time, it works. They are able to put a block into something, or they are able to have, if you have Duplo or Lego, and you're able to build a small tower or whatever. So what basically is happening is in the mind of that kid, a small connection is made, and the connection says this is good. Now, in the mind of that kid, there is nothing programmed. It is not a program where it goes like, if you do this, then that will happen. No, it's a neural connection. Now, if you take a look to how robots work in the industry nowadays, then we basically program them to do a specific action. We take something and move it from coordinate XYZ to XYZ accent or whatever. It's always the same. It's deterministic. And these machine learning algorithms, they try by just trying to do a certain action, and by then eventually succeeding in it, then they know, okay, like this seems to be okay. Now, by saying that, you understand that an AI algorithm, it doesn't have knowledge. It just knows that if I try to do something, well, this action looks to be the right one, right? And this is also how ChatGPT works. ChatGPT doesn't understand our language. What it does, it makes statistical connections to relevant words. So that means that if you would, for example, if you would train ChatGPT only based on the Harry Potter books, and you would ask ChatGPT to write a story which is in the style of Harry Potter, that will probably work. But if you will ask ChatGPT only trained on the Harry Potter books to answer a question about asset performance, for example, well, not a clue, obviously. And that brings us, of course, to one of the main problems we see is that do we have the right data to train our models? Do we actually understand when these models can be applied? And let's forget about smart models. Let's just make sure that we apply the right model to the right case. And that's why I dare to say that those models are pretty stupid.
Okay, yeah, because you touch on something very important. Do we have the right data? And then, of course, plants nowadays, they are really have the aim to produce constantly, etc. So there maybe there is a problem.
Absolutely. I think already 10 years ago, I gave a keynote somewhere at a conference with all people from the chemical industry. And I told, mostly plant managers, and I told them, I said, you guys are making my life really, really hard. And they laughed and they went like, okay. And I said, okay, you only want to have stable production. You want to have a plant who runs as smooth as possible. You want to hit a certain set point. You want to have, I would say, the least amounts of vibrations and deviations as possible. And you want to produce on spec, preferably 100% of the time, right? And I fully understand that. But from a data point of view, that data for me is completely, well, there is no value inside of that. I can't make anything out. I can't start making predictions. And one of the things which I always talk about when we're talking about digital maturity or data maturity is that one of the really important points is that we need to have data which actually holds value, which holds deviations inside it. And if we do not have that, that's fine. But then we need to have, I would say, we need to introduce other technologies, other ways of working to get insightful information. And one of those things is that we actually start making changes to the process. We are trying to make some deviations in that data. Now, that's always a very long debate.
Yeah. Well, I hope you don't do that with airplanes, for instance.
A very nice example, because indeed, actually, an airplane, when it's built, there is also a digital twin, which is modeled. 1, 2. When an airplane is tested, they are testing that to the limits. And it's only when they have a fully functional digital twin and the airplane has been tested by test pilots to the limits that they will actually approve that to be used. Now, in our industry, typically, we start up a plant. We are only busy with starting it up. We are really, really happy that it runs. And then we want to start running it as smooth as possible, as fast as possible, right? Yeah. And that's a challenge.
Yeah, I understand. So, well, on the other hand, there is a high demand of implementing artificial intelligence and digitization projects, etc. So, typically it starts with a proof of concept. So, well, what is your opinion about those proof of concepts? Omar?
Well, we have done quite a bit of proof of concepts the last, let's say, 3-4 years, trying to use predictive analytics with machine learning in various use cases. Now, my question to you, Wim, as BEMA's representative, would be, what do you think? Would be, let's say, a successful ratio of proof of concepts, because we have seen many throughout these years. What do you think?
Well, let's say we hear, of course, the success stories. So my opinion would be 100%, because we really hear the positive stories here.
Correct.
There you go, my estimate.
Yeah, but so in practice, what we see is that many of these proof of concepts, about 90% around machine learning in the industry, they actually fail. Wow. That's a high number, actually. Why is that? We just spoke about the airplanes. A lot of people forget that before the airplane is actually built, we have this full-fledged digital twin, but we actually create everything at scale. So we create a small airplane, a small-scale airplane, and we test it to the limit as well before we actually start building. And this proof of concept is actually critical. And a lot of people forget that they actually need to build a very good use case before starting the proof of concept. Do they have the data? A lot of people start with a proof of concept. They say, I want to get started with predictive maintenance. It starts already with the definition. What is predictive maintenance? Does it imply AI and machine learning? Yes or no? There it already creates a discrepancy, let's say. But do they have the data? And usually they don't have the data. Or they have just a small fraction of the necessary data to actually make the proof of concept work. Do they have buy-in from the management layer in the organization, the users? So this is all quite important to make the proof of concept work. Not only that, during a proof of concept, we need to adjust certain things, because throughout the proof of concept we learn that this is not actually what we thought, and we need to retrain, for instance, the predictive model. So are we busy with that? Yes or no? Do we have people looking at the output from the model and actually doing something with it? Yes or no? So these are all factors that make a proof of concept a success, yes or no. And what we see in practice is that most of the end users in the industry don't have, let's say, a yes mark or let's say an okay answer to these questions.
Well, I have a term for that, and it's called a pilotitis. So what is it's a medical, it's something really it's a really severe thing there. So what is pilotitis? Pilotitis is just starting off all these initiatives one after the other. We'll see what happens. But nobody takes a step back to reevaluate, to see what makes sense. Now the problem with pilotitis is in organizations, if you don't have if you don't have the right, I would say, a change process around the pilot or proof of concept, whatever you want to call it, we are introducing, then you will never get rid of this very nasty disease.
Yeah, and you say it. There is, you have your own terminology for it, but a lot of these proof of concepts don't even make the stage of go no go. Why is that? Because in the end, in Thiam, they discover that they don't have the necessary team to actually make it a success, and they put it aside. Usually, it fails around the use case build up. They see, okay, this use case makes no sense, so we push it aside. And then there are quite a few, let's say, but that is a minority of that 90% of the proof of concepts that, are basically swept into the trash can. Why? Because nobody is actually working on the POC. And of course, if you're not working on a POC, you can't meet the finish line. So that is also a factor.
So on the other hand, you have those successful use cases. So what do they have in common? So what are there the basic pushes, the basic situation that you need to have in order to succeed with digitization?
It all starts with how the management buy-in, but also the management culture is in the teams who are working on that. And we are talking now since 2000, I would say 15, 16, we're talking about this Industry 4.0 concept. We all know it, we all have talked about it. We as a vendor, it would be very strange if we wouldn't have used it in our marketing terminology. Yeah? So we all claim to be living in this Industry 4.0 era. And if I take a look to teams who are working on digital projects, I again dare to say something which, sorry for the fan mail again, we are still living in, I would say, in the era of Industry 1 and 2.0, in the era of Taylor and Ford. And why is that? That's because if we go back to 100 years ago, workers were seen basically as robots, right? A worker was a robot, in the end was tasked to do a specific thing over and over and over again. And then Ford had a clever idea to put a conveyor belt in between, but basically the concept stayed the same. It was a command and control concept, very hierarchical, top down. Now that works really well if you are doing something which you know. If there are only knowns to what you are making. Right. A bit later, these very famous Gantt charts were introduced with milestones and how long a certain task had to take. So that means that we had now a clear plan. Good, great. Now, if we transfer that to the world we are living in today, I see that many companies still work that way. So if we want to do a digital project of any kind, then we need a project plan, and we need to apply for a budget, and we need to do this and that, etc., etc. So basically, from 100 years ago. Okay. Now, if we take a look to digital projects, in comparison to our good friends Taylor and Ford, we only have unknowns. We rarely have knowns in the things we are doing because we typically don't know what will be in the data. We don't know what data will be. We don't know what technology we're going to use. We have all these unknowns. And that means that every project is unique, and that means that if you cannot apply those ways of working from the past to projects now now and also in the future. And that's where these terms from agile working, DevOps, those are terms who actually came in and especially are known in the IT industry. I would say in the typical IT industry, nobody is still using waterfall methods when they are developing a digital tool. But in the manufacturing industry or in the operational world, this is still a bit a strange duck. It's those are the two guys who are doing agile in our company, right? Now it's really important because there are some key concepts in working, and you know what? I don't want to say like you have to work fully agile, you buy the book Agile and work agile, or buy the book DevOps and work DevOps. That's not what I'm trying to state here. What I'm saying is that there are some important concepts that we need to apply to these projects. And one of these concepts is the fact that we want to create autonomous teams who have the autonomy to decide what makes sense for the project they are using. So that means that we give those teams the full flexibility to decide that, okay, I'm going to use technology A or B, or I need to do this or I need to do that they don't always need to knock on someone else's door, because then things get slow. And we also need to accept that those teams need to apply a fail-fast principle. A fail-fast principle is something which we do not like in the operation industry, because we want to be, as I said, as stable, as safe as possible. But I always say that my best friend is the undo button. I try something, it doesn't work, I undo it, I try it again, I restore a backup, doesn't matter. But in any case, I need to be able to try something, fail fast, do it again, over and over and over again. And part of the fail fasting is also to accept that you need to throw away stuff if it doesn't work. And that's also what we see from this old school management style of thinking. People go like, no, David, you applied for a budget. You will now keep on continuing until you have proven the thing, whatever you want to do. Let's say we're gonna predict failure of a compressor, or we're gonna predict falling of a heat exchanger, or whatever you name it. But management layers need to accept that stopping a project is as good as starting it. Right now, that's from the management point of view. If we take a look to the key success factors, that means that in those teams, they need to have access to data in a very, very easy way. The data needs to hold value, as I said earlier. And this one is really, really important. You need to involve process knowledge in the projects you're doing. There is no such thing as the holy grail in data science. There is no such thing as the algorithm to rule them all, right? The thing who will rule them all is knowledge about the things we're actually trying to solve. So that means that if we have teams where we have the technology or the mathematical point of view, we have the data access, and we have people who understand the process, if that comes together, then there is a really, really high chance of getting it right.
Yeah, well, you said it in your answer, but I want to dive a little bit deeper into this. You said, of course, they need to be able to choose the right technology, the right algorithms, etc. Yeah. So that means that you need to have a kind of digital infrastructure that really can work with these different approaches, etc., etc. So what is a good digital framework? What does it need to correspond to in order to be able to succeed there?
Yeah, well, Wim, that's a very good question, because David spoke about these autonomous teams. So in order to get the most of these teams, you actually need to start thinking about the data infrastructure for these type of machine learning and AI projects even before they actually start. Do I have the right infrastructure to actually start scaling as well? Because if I want to make this a success, of course, it needs to scale up. And so you need to make sure that you have a data infrastructure in place that can actually be this kind of digital thread throughout the company, that can provide real-time data, but actually also the right context. Because if you don't have the context of the use case you're working on, it will fail, definitely. So you need to make sure that it is available as well to those teams, that these teams can just access the data, work on their own, analytics project, and then make their own conclusions and make their little use case a success. And so for this, you need a good backbone, of course. And this backbone at Aveva, well, there is a great example of it. That's the PI system, the formerly OSI soft PI system. So we have embraced that fully at Aveva, and we really see this as the pinnacle of industrial information. The industrial information coming from different systems within the facility or the organization, not only the OT systems, but also usually the ET systems as well, and sometimes the the IT systems, because we want to leverage ERP data, certain financial data, etc. So this is key for a success in this new, let's say, day and age around AI and machine learning.
Yeah, and I wanna add something to that. Well, it is. I have to say I'm a bit geeky in this area. I always think about concepts regarding data platforms and management types and things, and actually also wanna say that I started writing a blog myself. It's called the IT OT Insider, and maybe we can put that in the show notes. And on my blog, I together with a colleague, I try to describe all these things, these small things people encounter and how we can help them. And with we, I don't even mean Aveva. I just mean how the world works. And if you talk about those data platforms, if the number one question people are asking me is about AI, good. The number two question people are asking me is data platforms. How are we going to combine all this IT data, OT data? And you have all these terminologies. We need to build a data lake. No, we need to build a data warehouse. No, we need to build a data platform. And I think what's really important here is to stress a couple of similarities and a couple of differences between the IT and the OT world. To start with, the IT world is mostly working with transactional relational data. ERP systems is an example, but typically we are working with transactional data. What is a data lake? A data lake is nothing more, nothing less than I have several data sources and I'm throwing it all in my lake at a certain place where I can easily access it. But at that point in time, it's just data. There is no structure over there. If people talk about the data warehouse, it's basically the next step, and that is adding structure to that data we were throwing all in our lake. So a data warehouse is nothing more, nothing less than a combination of data sources with structure applied to it. Okay, it's a bit, not fully right, it's a bit short answer, but that's the main thing. Now, if you compare that to what we know from the OT world, the OT world drives on time series data, on sensor data. And sensor data is not just a data point with a time attached to it. It's also about the quality of your measurements. It's about understanding, is my sensor actually working? It's about combining sensors. It's sometimes, if we talk about predictive maintenance, high frequency measurements to, for example, have to plot I would say vibrations, for example, in a pump or a motor or rotating equipment in general. And that means that this question about do we now need an OT data lake or an OT data platform, it actually comes up very, 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 very much. Now, in my opinion, if we take a look to OT data, to time series data, the first step, let's compare it to a data lake as such. We have 1,000, 10,000, 100,000, whatever sensors, and we're putting it in one system. The Aveva Pi system is one example. There are others as well. And this is kind of my data lake, right? Now, again, there is just data. There is no structure. There is no context. And what we need to do in our world as well is to make that same, I would say, step change and introduce this concept of a data warehouse. And so if we take a look to what the data warehouse could be in our OT world, that means that we need to have on the one hand assets information structure. That typically indeed comes from these engineering systems where we know, okay, this asset is part of that equipment, is part of that line. That's one part of this context. Another part of the context is actually your operational context. What were you producing? Which product? What was the quality? Now, today, these types of data, they are also still in different subsystems. So to come back to that original, I would say the original question I had about the data platform, in my opinion, one of the steps we, the industry, but also us as a vendor, will be taking in the next years and are taking also today, is introduce that concept of an OT data platform, where not just the data lake, so the time series data is present, but all this contextual information as well. And then in the years to come, I don't have my glass ball here with me, but what I think what will happen in 5 to 10 years is that this IT data world, data warehouse, data lake world, will start merging slowly with the OT data world. Today it's two different worlds, but I see them coming closer and closer together, and in the next 5 to 10 years, I believe we will go to one situation where we have one central data store including everything. It takes some time.
Yeah, well, companies are one of those sayings is that data will become or is the blood of a company. So
Absolutely.
Do you agree with that?
Absolutely. But I would say even more, and that's what we sometimes forget, the user. Because data without those users, without people who are actually mining, mining the data mining, I actually still like that word. Fun fact, when I started working in the industry, the term data scientist was not really invented yet. So I started as a data miner. Which I still like very, very much so. But we forget about our users. And it's actually funny, Wim, that it's our third point, I would say our third major point in our podcast. We should have taken it as a first one, but just to say that for me, technology, process management and users, they are equally important. And in our opinion, we expect too much from them, which means that we introduce something and we throw it over the fence into a control room or into a maintenance shop or you name it, and there you go, right?
Absolutely. So just to give the example, the analogy, and this is at the same time, let's say, I confess, this is a confession, I cannot cook. So this is the perfect analogy that I will give. I have a knowledge gap in cooking. If we, translate that into the industry, a lot of operators, technicians, you name it, engineers, they also have knowledge gaps nowadays because they have a clear and different way of living today. The educational system has changed as well, so they clearly come into, let's say, the economy as a different persona compared to their colleagues from 20, 25 years ago. So there is a clear knowledge gap. How do we make sure that we bridge that knowledge gap? And coming back to the cooking, if I want to be, let's say, a star chef in a restaurant, I want to make, my own restaurant, and I want 3 Michelin stars. I have basically 2 options if I can't cook. Either I follow cooking courses and I go step by step and make sure that I gradually build my knowledge and that I can maybe find the proper people as well to help me get to my 3-star restaurant, or I can just take a plunge into the big ocean, let's say, and run around in the kitchen of a 3-star Michelin restaurant. What will be the most effective? Well, I think the first one. So the second one will be a lot of chaos, a lot of...
You will be doing the dishes.
Oh yes,
you will be doing the dishes.
Oh, that's clear. Yes. So basically, we need to make sure that the user is gradually, assisted in their job, on the job, and making sure that we assure that the quality of work is in place. And by that we mean the knowledge should be built up gradually. We need to provide that knowledge also and manage it digitally more and more. And so this is, in my opinion, a clear factor that we often forget in all these digital transformation projects. We shouldn't forget about the user, and certainly not the profile of the user nowadays.
I will add a funny story about actually exactly what you mentioned. So some years ago, we were making a mathematical model to predict a certain thing happening in reactors. And we actually applied machine learning algorithms, and that's more than 10 years ago. We actually applied machine learning algorithms to try to predict this issue. And so we had these really cool models, and the model basically said two things. Everything is okay, or something might be happening in your reactor, so operator, please take appropriate action. Now the problem is that they couldn't see inside that reactor, so the only thing they could be using was they had to look to their pressure and temperature measurements and so on. Hopefully see some deviations, but the problem is the deviations weren't visible, because that's why we are applying machine learning algorithms, because we wanted to start combining all kinds of different factors. So we had an internal name we used for our model, but the operators, they called that the oracle. And why did they use it, the oracle? Because they went like, yeah, that thing says good or not good, but we don't know why. We don't know what's the impact on our job. Should we actually stop the process, yes or no? We don't know. The thing, the oracle says so. And that's why they called it the oracle. I always found it very, very, very funny. And unfortunately, I would say our process specialist, the oracle was there was one process expert we used from that plant. And yeah, the day he left that plant, the oracle died with him. Because the operators just went like, yeah, throw it out. And that's what we are saying here, is that how good the technology is, how fancy the model might be, if you don't have the buy-in, forget it.
That's it. You need to use a buy-in. And what does a user require nowadays? It's accessible information, but also let's not forget that the forgetting curve of the user nowadays goes down very fast, even faster than before. If we look at the YouTube generation, they are used to, consume information rapidly, but they forget it rapidly as well. And so if we don't make sure that, we have the proper tools to actually visualize the context and the information to the user so that they can constantly, work on their reinforced learning, to give some machine learning terminology, it doesn't work. Yeah. So you need to buy in from the user according to their own profile. That is essential.
But in fact, David, you gave already a presentation earlier at the Asset Performance Conference about the project in the chemical industry, where this accessibility to data was the key point.
Absolutely, yes. So I used to work for BASF, and until now, we talked about data, about predictive modeling, and so on and so on. But there was actually another topic, and that was a topic of my previous presentation in Corona time. So it was a virtual one, fun. And that was not about data, but about something else, which might be really, really interesting to maintenance and reliability people, is management of change, the digitalization of the management of change processes. The good thing here is that we always say, you need data. But on the other hand, you have so many paper processes still in place in those plants. Already, we have a product called Mobile Operator, where we provide a smartphone to the operators to go in the field and make annotations, start work orders. BASF does more than 25,000 of those inspection rounds per year with Mobile Operator. Now, all that data now becomes available in an underlying data system, so we can start doing clever things with that. And now, if you compare that to the topic I talked about 2 years ago, was digitalization of the permits process, where we are still using paper permits, which means that people, they wait in a queue to get their permits, they go out, maybe they need to sign off their permits on the right spots, maybe with the 4I principle. Are we at the right spot? Did we bring the right equipment? All those things. No, we forgot something. We go back in. In many cases, you have a chain of permits which gets released. So that means that before my chain gets released, I first need to go inside whatever container or shed is placed, and I need to wait for my follow-up permit, etc., etc., etc. And suppose that we are there in the field and we have our signed permits, then I suddenly come to the conclusion that I need some more situational awareness, meaning I would like to see a work procedure. I would like to see a PNID. I would like to see, for example, actual real-time data of is this line actually out of use, yes or no, or whatever you want to call it. We are talking here about, at Aveva, we try to use the word connected worker. We would like to make sure that people who are outside, they are connected to everybody else, basically. And it's fun because you also said that the new generation, they use their smartphone. Me, I as well. Well, I use my smartphone for everything. But the first thing I do when I enter, for example, a chemical environment is I need to leave my iPhone at the wherever I need to leave it, but not in the ATEX zone, obviously. And having said that, I fully understand that I can't bring something in an ATEX zone, but we do have very good smartphones, very lightweight smartphones, which you can use in ATEX environments as well. But then what I saw is you now have this smartphone, and the smartphone has one app or two apps, and that's it. And then even worse, you see situations where they're not only using one smartphone for one use case, they're using a tablet for another use case, and then maybe their walkie-talkie because they still need mission-critical communications.
Yeah, and so do you see some evolutions in technology that really enable data access also in these difficult zones?
Oh, absolutely. So there are, I would say, on the one hand, devices become available, and they are lighter and lighter. They are not, the first ones I used were really bricks. It's 1 kilogram and more, which is, anyways, we're past that already for a couple of years. From the software side, we are seeing the introduction of more and more low-code, no-code platforms, which makes it really, really easy for people to start building their own small apps to have certain use cases. One of the software we used at BASF for the digitalization of these permits is called Aveva Work Tasks, which is... So, which is indeed a low-code platform where you can actually build workflows, and that means that you can have you can build a mobile app which interacts with other systems, which gets data from ERP systems, from planning systems, from warehouse systems, which send notifications back to certain workers, etc., all in this low-code fashion. Now there is a small, I would say, caveat with low-code, no-code is that this can also become, let's name it Excel 2.0. We all know the Excel problem. Everybody builds their own Excel, maybe some VBA code. Then whoever built it leaves the company or retires or whatever, and then knowledge is gone, right? So what you do need, and that's where Aveva Work Tasks really, really shines, is to also capture the knowledge about the processes. So it's not only a low-code platform; it's also a knowledge capturing platform, and it captures the process you are going to execute in the field, right? And then lastly, I think also the introduction of 5G is really important. I've always been a great advocate of going from 4G to 5G. Why? Not because of high bandwidth. We typically do not want to stream full or 4K movies inside a plant. But there are two things which are really important. The one thing is that because 5G is capable of working on lower frequencies, that means that we have a deeper penetration in steel or in concrete buildings, which is really important for the industry, and there's also the possibility to build private 5G, which gives you the possibility to even install antennas inside your own facilities, which is really hard to do with 4G. And the second thing is the introduction of mission critical communication, which means that in the future we will have the possibility, if something goes wrong, that we can still guarantee the availability of 5G And then, this could lead to, for example, just have one device, and we don't need the walkie-talkie anymore. We just have one device to rule them all.
Yeah. Okay, so power to the people, data to the people. That's so. But if we take the point of view of a maintenance manager, so what can you do there to increase success and in order to achieve success?
I would say first, as a maintenance manager, you need to be aware that, or you are already aware that we live in a day and age or an era with a lot of distractions. So you need, as a maintenance manager, systems, but also processes that help your users, your maintenance engineers, your technicians, etc., whether working in-house or externally, working on the site. They need to make sure that they have the proper digital aids in decision making. First of all, without distractions, that is very important, so that they know which are the priorities and that they can, leave aside the lower priority notifications, basically, what David was talking about earlier. And then secondly, also managing the users, because with all the different systems, as a maintenance manager, you have your CMMS or EAM, you might have your real-time systems coming from productions, etc. So there are many, many tools, and maybe ERP as well. So there are many, many tools. You need to manage the pitfall of digital tiredness as well, of your users. So please be aware that, you need a company, you need a vendor, or a partner, better yet, that understands that change management as well. Manage those users. Make sure that the use case is properly set up before actually doing your digitization project, whatever it might be. And so that is essential for any maintenance manager nowadays, is don't look at, the next greatest thing that you saw on the internet that claims, to be out-of-the-box software that can cover, all your use cases in maintenance or asset performance management. Usually that never works. Look for the proper partner that can find the right integration partner, that can understand the user's frustrations and needs, and help you in, get that use case through, thick and thin, and make it a success. That is basically what I wanna point out. And for that, we are also, let's say, putting ourselves at the forefront. We not only claim to sell the software, but really help the users, get the most out of their use case.
Yeah, and you have to understand well, it's also about making things more simple instead of making them more complex.
Absolutely. So in order to make your digital transformation project a success, don't overcomplicate things. So as we said earlier, get the proper buy-in from management, find the proper technology, and make sure that you have buy-in from the user. So don't overcomplicate things. Don't look for the most complex use cases. Go for the easy, quick wins. And make sure that you have the proper partner to assist you with that. So don't overcomplicate it. That is certainly one of our points of advice.
Yeah. And if I take that maybe as a closing thought, one of the things I think in my previous job, when I was responsible for the implementation of those technologies, one of the most important things was to say no instead of saying yes. Because everybody would like to participate. Everybody has questions. Everybody has ideas. And that means that saying no is actually more important and also more difficult than saying yes to a question. And that's where good scoping and a good project starts.
Yeah. And building your core team. Don't make it too big.
No.
And so the more people that are involved, the bigger the chance of failure. So have a core team that can make the right decisions. Absolutely.
Thank you very much. I think with that, it's a very interesting conclusion to this very entertaining conversation that we had about asset performance, how to implement it, and what are the caveats and what are the success factors. So I found it very inspiring. So thank you very much, Omar. Thank you very much, David.
My pleasure.
Thank you, Wim.
And
it's
we
a pleasure.
are looking forward to have you at the Asset Performance Conference in the
We are looking forward to it as well.
Absolutely. Thank you.
You're welcome. See you later, guys.
Bye-bye.
Bye.